Okay, so we're looking at right triangle applications. And so basically, if you're given a right triangle, we've been looking at before being able, given some information about sides, being able to find another side. Now we're going to be able to extend that and being able to find angles given information about a right triangle. So for instance, let's say you have this right triangle. And you're given that side B. This is angle B over here. This is angle A up on the top. And this is angle C. This is B, little c, and little a. And we're given that little b is equal to 4. Capital A, which means that's our angle, is equal to 25 degrees. And we want to find the rest of the pieces of this triangle. Okay, so we could figure out what our other angle is because we have this angle in here and we have a right triangle. We know that the sum of all the 3 angles in a triangle should be 180 degrees. This is a right triangle, so the sum of the other 2 should sum to 90 degrees. And so angle B, we can say, well, this is the same thing as 90 degrees minus 25 degrees, which is 65 degrees. And so now we can use either angle A or angle B to figure out what side A is or side C. So just choose one of them. So let's say we just chose the one that we're given. So if we chose angle A and we want to find, let's say, side A. Let's think about from angle A, we have the adjacent side and we were trying to find the opposite side. And so you have to think about which trig function would you use if we're dealing with opposite and adjacent. So tangent deals with opposite and adjacent. So we know the tangent of angle A is equal to the opposite side all over the adjacent side from that angle. And so the opposite side is A. The adjacent side is 4, is equal to, and A is 25 degrees. So we can figure out what A is, multiply both sides by 4. So we know that side A then is equal to 4 times tangent of 25 degrees. Okay, so if I didn't have the calculator on the exam, then this would be the exact form. And so there's 2 different ways that we can deal with finding side C. We can use our Pythagorean theorem, or we can do the same thing that we were just doing. So let's just do it that way. So if I wanted to find side C, let's look at angle A, and we have the adjacent side and we want the hypotenuse. So think to yourself, which uses adjacent and hypotenuse, which trig function, and that is cosine. So we know cosine of A is equal to the adjacent over the hypotenuse of A. Well, the adjacent side is 4 all over the hypotenuse of C. So cosine of 25 degrees is equal to 4 over C. So if we multiply both sides by C and then divide both sides by cosine of 45 degrees, then we can get C by itself. So we get C is equal to 4 divided by cosine of 25 degrees. So if you're plugging these in the calculator, make sure your calculator's in degree modes and not radian mode. So if I was looking at the first one for tangent of 25, that was approximately 1.86. Or actually 1.87. And then if we looked at 4 divided by cosine of 25 degrees, you get that's approximately 4.4. So it's pretty much just using our knowledge of the ratio of sides of trigonometric functions to find the unknown of this right triangle. Let's look at another one where maybe we don't even know what the angle is. So on this one, you're given what all 3 sides are, but we're not given an angle. So we're given that side A is 7, so the bottom length is 7. Side B, that length is 4, and we're not even given the hypotenuse. Okay, that's fine. So let's find side C, angle A, and angle B. So it doesn't matter where you start. Let's start with C first, just because that's something we've been doing. So Pythagorean Theorem, we know that C is going to equal the square root of 7 squared plus 4 squared. So 49 plus 16. So C is equal to the square root of 65. Okay, so to find angle A or angle B, I would use the information that they gave us. So let's say B this time. So if we're using angle B, or we want to find angle B, let's look at angle B. We are given the opposite, which is 4, and the adjacent, which is 5. And so again, think about which trig function deals with opposite and adjacent. So tangent of B is equal to the opposite, which is 4, all over the adjacent, which is 7. So we're going to now figure out what B is. We were looking at last week, if we had some angle that we were trying to get and we didn't know it, we could take the tan inverse of both sides. So I'm looking at the tan inverse of tan B is equal to tan inverse of 4/7. So this is not an angle that we know. So I don't know tangent of what gives me back 4/7, but I can use my calculator. And so looking at tan inverse in the calculator, again, make sure it's in degrees of 4 divided by 7. So if this, we get approximately 29.74 degrees. Okay, so there's 2 separate ways to figure out angle A. We know that the sum of B and A have to be 90 degrees, or the sum of all 3 angles is 180 degrees, or we can use inverse trigonometric functions. Let's just do that because this is just part of this section. So if I was going to figure out what angle A is, I would look at angle A, I would look at the ones that were given versus the ones I just found, because if I made any errors in my work, then that would show up here too. So I would look at, okay, again, I have opposite and adjacent from this angle A. And so I would again look at tangent of A is equal to the opposite of that, which is 7, all over the adjacent, which is 4. Again, taking the tan inverse of both sides, we would get A then is equal to the tan inverse of 7/4.
Wait, why did you do 7/4? What?
Because from angle A, the opposite is 7 from A. And
Oh, okay, got it.
Is 4, yeah. So angle A is approximately 60.26 degrees. Or we could have gotten that again by 90 degrees minus 29.7.
Professor, I had a quick question. Is this a new chapter in chapter 9, or is this review?
This is a new chapter in chapter 9. It's 9.1, but it's a lot of it is kind of ties into a review of what we've done in the past.
All right, thank you.
Yep. So if you had done 90 minus this 29.74, you would also get 60.26 degrees. But I just wanted to show a different way of doing it with a tan inverse. Okay, so let's look at a couple word problems using these. So read through the word problem. Sometimes drawing a picture is really helpful. And then put in all the pieces that you know or equations that we know that will help us solve. So let me first just read through the problem, and then we'll start writing down some of the information. So a surveyor is measuring the distance across a small lake. This sounds familiar. He has set up a transit on one side of the lake, 120 meters from a piling that is directly across from the pier on the other side of the lake. From the transit to the angle between the piling and the pier is 40 degrees. What is the distance between the piling and the pier to the nearest foot? Let me turn that, sorry, turn that off. Okay, so we got a lake. We're trying to find out a distance. So surveyor is measuring the distance across a small lake. He has set up a transit on one side of the lake. Anyone know what that is? So he set up a transit one side of the lake, 120 feet from a piling that is directly across from the pier on the other side of the lake. To see the piers on the other side of the lake. So he has set up a transit on one side of the lake, 120 feet from the piling that is directly across. So here's some piling. This is 120 feet. From his transit, the angle between the piling and the pier is 40 degrees. Okay, so the angle between the piling and this pier is 40 degrees. What is the distance between the piling and the pier to the nearest foot? Okay, so we want to try to figure out what this length is in here. Okay, so looking at our triangle, look at the angle that you know, which is the 40 degrees. We're trying to find the opposite from the 40, and we know the adjacent from the 40. So that should clue you in to use tangent. So tangent of 40 degrees, this is equal to the opposite, which is x, over adjacent, which is 120. So multiply both sides by 120. We get x is 120 tangent of 40 degrees. That's not one we should know, so we can plug that in the calculator or leave it like that if you didn't have one. So x is approximately, and it wanted it to the nearest foot. I have 100.69 feet, so 101 feet. Okay, so next one, a radio transmission tower is 150 feet tall. How long is the guy wire be if it's attached 12 feet from the top? And is to make an angle of 21 degrees with the ground. Give the answer to the nearest tenth of a foot. Okay, so we got some antenna, radio transmission tower. And it's 150 feet tall. And then there's some guy wire, which I never knew until I had taught trigonometry what that is. But basically it's a wire it's forming down here with the ground. Attached. Let me just make sure. How long should a guy wire be if it is attached 12 feet from the top? Sorry, 12 feet from the top. I guess this could be 12 feet from the top. And is to make an angle of 21 degrees with the ground. Okay, so basically, if we have 12 feet from the top, then the length and the whole antenna is 150 feet. Then for our triangle, this is going to be 150 minus 12. So we're going to have 138 feet. It's a little messy. And we know that this is 21 degrees. And we're asking, how long should the guy wire be? So we're trying to figure out our hypotenuse. Let's just call it X. So from the angle that we're looking at, 21 degrees, we're given the opposite and we're trying to find hypotenuse. So now you're thinking of to yourself, what uses opposite and hypotenuse? So hopefully you all came up with sine of our angle, 21 degrees equals the opposite, which is 138 feet, all over the hypotenuse x. So if we multiply both sides by x to clear our fraction, you get x sine of 21 degrees equals 138. Divide both sides by sine of 21. We get 138 divided by sine of 21. And so that's approximately, and it's said to the nearest tenth, 385.1 feet. So these aren't that bad. Maybe I shouldn't have said anything. Let's look at another one. John, whose line sight is 6 feet above horizontal, is trying to estimate the height of a tall oak tree. He sounds like something I might do. Anyways, he first measures the angle of elevation where he is standing as 35 degrees. He walks 30 feet closer to the tree and finds that the angle of elevation has increased 12 degrees. Estimate the height of the tree round to the nearest whole number. Okay, so we got John. His line of sight. So let's make a horizontal. So his line of sight is 6 feet above the horizontal, basically the ground. And he's trying to estimate the height of the tree. He first finds the angle of elevation from where he's standing to be 35 degrees. So remember we were talking about angle of elevation and angle of depression. Angle of elevation or depression is always from the horizontal line. Elevation would go up, depression goes down. And so we know that he has 35 degrees angle of elevation. And then it also tells us that he walks 30 feet closer to the tree. It's changed color since he's walked. And now from this angle of elevation, he finds that it has increased by 12 degrees. So we know that his new angle has to be that 35 degrees plus the 12 degrees, which is equal to 47 degrees. So estimate the height of the tree round to the nearest whole number. Okay. Let's think about we know his height. We know that this length in here is 6 feet. So let's think about that later when we're trying to find, let's right now find this length. And then we would know that we have to add the 6 feet in here. So we have a right triangle. Notice that we have two separate right triangles. So let's look at the bigger one. In the bigger one, we have 35. We have that this is 30. We don't know what this piece is. Let's call it X. And we also need to figure out what this piece is. Let's call it Y. So right here, this piece right here, I'm going to call X. This piece I'm going to call Y. Okay, so I'm trying to find the opposite, and we know somewhat of the adjacent. And so that tells me I can use tangent. So tangent of 35 degrees is equal to the opposite of that side, which we called Y, over the adjacent of that side, which is the sum of 30 plus X. Okay, so let's look at the smaller triangle that we have in here. So we have this smaller triangle in here. We know that this angle in here is 47 degrees. This is still Y, and this is still X. Okay, so again, we can use information. So the angle that we have, we are trying to figure out opposite, and we know somewhat about adjacent. So tangent of 47 degrees is equal to Y over X. Okay, so we have two separate equations, two unknowns. And so we can use our substitution method to be able to find what what one of the unknowns is. And then we can figure out what the other one is. I'm just going back to see if I missed any information. No. Okay. Technically, I really want to figure out what Y is. So it would be better if I got X by itself and then substitute that value in to give me what Y is, because that's my ultimate goal. I don't care how far away I am from the tree once I walked 30 feet closer. I'm just curious on how tall that tree is. And so let's solve for X. And so it looks like this would be the easier one to solve for X. So solve for one of the variables. In one equation. Okay, so if I wanted to get X by itself, I would clear my fraction first by multiplying both sides by X. Once I've done that, we could get X is equal to tan of 47 degrees. Oops, sorry, X times tan of 47 degrees is equal to Y. Okay, well that's Y, and I could go back in here and plug that in for Y and solve for X. But again, I'm trying to get what X is, so it will be easier if I just rewrite this. So x is equal to let's multiply both sides by tangent of 47 degrees. So y times tangent of 47 degrees.
Wouldn't it be divide?
Oh, sorry, you're right. Divide both sides by tangent of 47. Okay, so we're going to be putting that in wherever we see an x in this equation. So use substitution. So doing that, we have tan of 35 degrees is equal to y over 30 plus x, but x is the same thing as y over tan of 27 degrees. And I want to solve for y. We can clear our fraction.
Where did the 27 come from?
I have no clue. It should be 47. There we go. Thank you. So let's multiply both sides by this denominator. If we did that, we would have 30 plus y all over tan of 47 degrees. That's all multiplied by our tangent of 35. Is equal to y. So let's distribute. So if we distribute, we get 30 tangent of 35 degrees plus y times tangent of 35 degrees all over tangent of 47 degrees equals y. So notice there's two terms with y in here. So let's get all the terms with y on one side and then factor it out. So if we subtract this tangent 35 over tangent of 47 on both sides, we would get 30 tangent of 35 is equal to y minus y of that tangent of 35 over tangent of 47. So factor a y out of both of those. So if we pull out a y from both of those terms, we would be left with 1 from the first grouping minus, and we'd be left with tangent 35 degrees over 47 degrees for the tangent 47 for the second grouping. And this is still equal to 30 tangent of 35 degrees. So divide both sides by our parentheses, we get y by itself. It's ugly, but we got it. Y equals 30 tangent of 35 degrees, all divided by this 1 minus tan 35 degrees over tan of 47 degrees. Okay. I'm going to do this in pieces. So tan of 35 degrees. This is approximately 21. All over 1 minus tan of 35 divided by tan of 47. I get approximately 0.35. So 30 tan of 35 divided by my answer. I get approximately 6, and it said round to the nearest foot, I believe. Nope, nearest whole number. Okay. That's not the height of the tree though. This is the height from his sight level. Because it was telling us that he was 6 feet tall. So approximately 67 feet tall. Tree. Okay, so that was a little more extensive and more kind of having to use some algebra, multiple equations, system of equations, substitution. So I think that's probably a good amount for 9.1. Let's actually take a break and then come back and we'll review for the test tomorrow.
All right, sounds good.
Okay. Okay, so we're just reviewing now for the exam that's tomorrow. And so let's just I'm pulling examples from the back of the review in your book. And so some of them are pretty fast. And for example, if you had tangent inverse of 1. And so find the exact value of each expression. So tangent inverse, our result, theta has to be between, and because this is given to us as an inverse, we have to limit this between negative pi halves and pi halves. It's positive, so I know I'm in quadrant 1, so I have to be between 0 and pi halves. I know that tangent is the same thing as sine over cosine. I know sine and cosine are the same values at 45 degrees, but this was given to me in, it didn't say radians or, it didn't say either, but it is, the answer is in radian. So 45 degrees is the same thing as pi fourths. If we were given sine inverse of negative 1/2. Again, I know that for sine inverse, I'm given the function with an inverse in it. That means my domain had been limited, so that sine had an inverse function. And my domain for sine inverse is, again, the same thing up here, negative pi halves to pi halves. I notice then that my sine value, sine inverse of that value is negative, so I have to fall in quadrant 4. But I'm going to express quadrant 4 as between negative pi halves and 0. I then ignore the negative and I think to myself, okay, what sine value gives me positive 1/2? Well, that's 30 degrees or pi 6. And so reference angle, to get that down into the fourth quadrant, I would write that as a negative pi 6.
Oh, one more question on that. So you said like the domain was negative pi halves to pi halves, right? And you said that since it's negative, that makes it quadrant 4.
Right. But they express their, when we're expressing it, we just express that quadrant 4 in this case as negative pi halves to 0.
Okay.
We could express it as 3 pi halves to 2 pi, but for inverse functions, we're going to do it this way. And if it's a cosine inverse, though, our range is between 0 and pi. These, we can include it. These, we actually want to include the inequalities technically. Tangent, we don't, because these are actually where our asymptotes are lying. And if we wanted to find cosine inverse of, let's say, negative √3/2. So I think to myself, well, cosine inverse of a negative, that's telling me my quadrant, the value of cosine that would give me back a negative has to be in quadrant 2. So it has to be between pi halves and pi. And then I would think to myself, okay, cosine of what angle is √3/2, which is 30 degrees, or pi 6. So in order to get that pi 6 here, I'm thinking to myself that I'm looking at pi minus pi 6. So 6 pi 6 minus a 1 pi 6, that would give me back 5 pi 6. So sine inverse of sine of 3 pi 8. We can just drop this if this 3 pi 8 falls in the domain, in the range. So the range has to be, because we have a sine inverse already in this, has to be between negative pi halves and pi halves. So my question is this, oops, jumping, is this 3 pi halves or 3 pi 8? Is this contained in quadrant 1? So how can I show that it is in quadrant 1 or not in quadrant 1?
Convert it to degrees.
So yeah, I would probably convert that to degrees because I don't notice what that angle is. So going to degrees, we're going to multiply by that's the 180 over pi. So pi's cancel. Let's simplify a little bit. So 8 and 18, I know have at least 2 in common. So 2 goes into 8 4 times. 2 goes into 180 90 times. Okay, so we got more. 2 goes into 4 twice. 2 goes into 90 45 times. My pi's cancel, so I'm left with 3 times 45 in my numerator, all over 2. 3 times 45, so that's 15, that's 135, all over 2. 2 goes into 13 6 times with a remainder of 1. 2 goes into this 15 7 times with a remainder of 1. So this would be 770 I'm sorry, 67.5 degrees. Okay, so it does fall in quadrant 1, so we can just drop this. So this theta, this is contained in quadrant 1. So our answer then is just 3π8. Where if that had been, let's say, how about this one? Tangent of sine inverse of negative √3/2 So theta has to be, for sine inverse, getting back in negative, has to be in quadrant 4. So theta, we can see, has to be between but we're going to write it between -π/2 and 0. So think to yourself, what gives us a positive √3/2? Sine of what value? 60 degrees or π/3. And so this has to be, but it's negative, so it's going to be negative π/3. So we're actually looking at tangent of negative π/3. So tangent of positive π/3, that's √3. But tangent of negative π/3, tangent's negative in quadrant 4. So this is negative √3. So sine of cotangent inverse of 3/4. So at any point, if this is something that we don't know, then we can always rewrite it as a triangle. So let's rewrite cotangent inverse of 3/4 as theta. So let theta equal cotangent inverse of 3/4. So that means if we take cotangent of both sides, we get cotangent theta is equal to 3/4. Cotangent's the same thing as 1 over tangent. Tangent's the same thing as opposite over adjacent. So cotangent is adjacent over opposite. So let's make our triangle. So if we put theta here, adjacent is down here, 3, opposite is 4, and we need to figure out what the hypotenuse is.
Do we know what quadrant this is in?
We can determine what quadrant that is in because of we're dealing with cotangent inverse. And so we have to think about when is cotangent inverse. It's positive. So theta has to be contained in quadrant 1. So find out what that value is. Using the Pythagorean theorem, C is going to equal the square root. 3 squared is 9, plus 4 squared is 16. Square root of 25 is 5. So right now we have sine, oops, of theta and so sine is opposite over hypotenuse. So opposite is 4 over hypotenuse, which is 5. And again, because this was positive, cotangent is positive in quadrant 1, and we have the inverse function, so we had to limit the domain of the original cotangent so that it would have an inverse. Okay. So it says write each trigonometric function as an algebraic expression in U. So if you had cosine of sine inverse of U. So write each trig function in terms of U. Okay, so we're gonna, again, create a triangle. We're gonna let some value, some variable be the sine inverse of U, and it doesn't matter what you choose. So we could say x equals sine inverse of U. So if we look at sine x equals sine inverse, or sine of sine inverse of U, so that would equal U. Let's look at that as a ratio, so U over 1. It's actually an angle, so x. Sine is opposite, so this is U. Hypotenuse is 1. So we're going to have to figure out what this length is right here. So this length in here is equal to the square root of the hypotenuse squared, which is 1 squared, minus this other leg squared, U squared. I cannot take the square root of both of those pieces and drop the radical because of this minus in between. So don't do that. So we're almost there. Well, we're actually basically there. Now we can find all of our trig functions. Well, this is the one that was given. So cosine of our trig function at x is equal to, well, cosine is adjacent, so that would be the square root of 1 minus U squared all over the hypotenuse, which is 1. Tangent. This is equal to opposite over adjacent. So opposite would be U all over the adjacent square root of 1 minus U squared. My guess is there's no radical there. So let's multiply both the numerator and denominator by square root of 1 minus U squared. And we get U square root 1 minus U squared all over 1 minus U squared. Cotangent of x, well, that's a reciprocal of tangent of x, so I don't have to get rid of my radical in the denominator. Let's look at the reciprocal of U over the square root of 1 minus U squared, so that would give us square root of 1 minus U squared all over U. Cosecant of x is the reciprocal of sine of x, so that would be 1 over U. And secant of x, that's a reciprocal of cosine of x, So that would be 1 over the square root of 1 minus u squared. Rationalizing the denominator and simplifying, you get the square root of 1 minus u squared all over 1 minus u squared. And then there were the proofs. So showing that identities hold true. So this is where you could only work on one side of the equation.
Professor, I have a quick question.
Yeah.
So on the previous one, when you solved for the triangle and you got the 1 minus u squared,
Yeah.
the original formula for that, it's r squared equals a squared plus b squared under a root, right?
Be careful. It depends on which one you're looking at, if you're what the hypotenuse is. So if we're looking at c squared is equal to a squared plus b squared, like this is my c, this is my a, and this is my b value, I'd have to, in order to get b by itself, I'd have to subtract this one. And so b squared is equal to c squared minus a squared. So that's why the minus is in there on that one, because we were looking for the side of a leg instead of the hypotenuse. If it's the hypotenuse, and it's the sum of the squares of the legs.
Oh, okay, got it.
And I noticed that, and I don't know if it was you or not, but that there was an error like that on the exam that someone kept on doing, was the addition instead of the subtraction in between. So I'm glad you brought that up. Does that make sense though?
Yeah, it makes sense. It's because you just like did the formula, so that's why.
Yeah.
Yeah, that's why. Because I'm like, I need to see like all the steps to understand it. That's why I was so confused. But thank you.
No, thank you for saying that, because I am starting to jump some certain leaps of steps that I used to show all the time, and that was one of them. But I will try not to do that as much. So showing following identities are true, you need to only work on one side, and you only choose one side, and you identify which side you're going to work on. So for instance, if we want to, and I'm just pulling one right out of here, so I haven't even tried it. Let's see, you have cosine of alpha minus beta. This is all over cosine of alpha cosine of beta. And we want to show that this is the same thing as 1 plus tan alpha tan beta. So look at which side you want to work with. Usually you choose the more difficult side. Both look like they're kind of difficult. I would probably work with the left-hand side because I see that I have a difference of angles here for cosine, and I know I can break that up into cosine cosine plus sine sine. And I also know sine over cosine is tangent. So it looks like this one might fall out pretty easily. So using the fact that cosine of alpha minus beta, sorry, I probably should put that glove on so I don't keep doing that. So cosine of alpha minus beta, this is equal to cosine is cosine cosine, so cosine alpha cosine beta plus opposite sign sine alpha sine beta. And we're putting that all over this cosine alpha cosine beta. So if you don't mind, let's break that up as two separate fractions as we do that. So that's the same thing as the first grouping over our denominator, cosine alpha, cosine beta, plus our second grouping, sine alpha, sine beta, over our common denominator, cosine alpha, cosine beta. Well, cosine alpha over cosine alpha, that cancels as 1. Cosine beta over cosine beta cancels as 1, so we're left with 1. Plus, we'll think of this as two separate fractions multiplied together if you want. And so sine alpha over cosine alpha, that's tan alpha. And sine beta over cosine beta, that is tan beta. So we just got back to what we wanted, was that this left-hand side looked like the right-hand side. So we did it. So I don't know if you guys want to see more proofs or maybe jump into other bits. Probably jump. So find the exact value of sine of 165 degrees. So if I look at 165 degrees, I would first see if I knew that angle. So I go, and this is 90. So 90 plus, well, 75 would get me up to 165. So 75 degrees. That's 15 degrees to 180. And I don't know what the angle of 15 degrees is. So, but I all know that I know 30 degrees. And so if I multiply 30 by 2, I could think of this as maybe a half angle could do it. So there's multiple ways we can do this. So let's try that. Let's look at multiplying 165 by a fancy one. So let's multiply this by 2 over 2. So if we did that, we would get back sine of 165 times 2. Is 330 degrees all over 2. So I notice I can use my half angle formula. This would equal plus or minus, and we'll determine in a minute if it's positive or negative. The square root of 1, sine was minus cosine of the angle before you divided it by 2, so 330 degrees, all over 2. We have to look at where theta is. So notice that theta, 165 degrees, is contained in quadrant 2. And sine in quadrant 2, we're dealing with a sine function, is positive. So this is equal to plus or minus the square root of 1 minus, so cosine of 330 degrees. Well, reference angle in here is 30 degrees. 30 degrees in quadrant 4, cosine is positive. So it's the same thing I would get for cosine of 30, which is root 3 over 2, all over 2. So let's get rid of this complex fraction underneath that radical, and we can do that by multiplying again by a fancy one. 2 over 2. So this gives us the square root. Got to distribute that too. So 2 times 1 is 2 minus, but 2 times square root of 3 over 2, those 2's cancel, just leaving with root 3, all over 2 times 2 is 4. Square root of the numerator, 2 minus root 3, all over the square root of 4, which is just 2. Okay, but that wasn't the only way you could have done that. That's one that you could have probably rewritten as a sum or difference of two angles that you know. And so in order to do that, to start either adding 30 or subtracting 30 from 165 and see if that brings you to an angle you know. If that doesn't, then do the same thing with 45 degrees or then 60 degrees. So I'm gonna jump.
So for these types of formulas, you can either do this or the sum or difference formulas.
Yeah, so with an angle you don't know, a lot of times you can manipulate it as a half angle like this into something that we do know, or you can manipulate it as a sum or difference of ones that we know. So like 165 degrees. So if I added, let's say 30 degrees to here, that's 195 degrees. Let me think about 195 degrees. I don't know that one. This is 180 plus 15. So that did not work adding 30. If I took 165 minus 30, I guess this is not going to work either. 5, 3.
How about 165 plus 45?
5, yep. So 165 plus 45, that's going to give us to 210, which is one we know because that's 180 plus 30. So 165 degrees could be expressed as 210 degrees minus 45 degrees. So our sine of 165 degrees, we could rewrite as sine of 210 degrees minus 45 degrees. And now we can use the difference of angles for sine. So sine is sine, cosine, same sign in between. So sine of the first angle, 210. Cosine of the second angle, 45. Same sign in between minus, sine of the other angle, 45. Cosine of the first, 210. So this is 30 degrees in here. And this is 210. So you have to determine we're in quadrant 3 and what's positive and what's negative. They're both negative in quadrant 3, and both of them in 45 degrees is quadrant 1. They're both positive. So I think of my reference angle, which is 30 degrees, but sine is negative in quadrant 3, and 30 degrees cosine is 1/2. Cosine of 45 is root 2 over 2. Minus sine of 45 is root 2 over 2. And cosine of 210, that's negative because we're in quadrant 3, and that's root 3 over 2 for cosine of 30 degrees. So this is negative root 2 over 4. Negative times negative, so plus root 2 times root 3 is root 6. All over a common denominator of 4. So I could just write that as one fraction.
Yeah, this way I was struggling a lot with the previous one, and right now that you said we could use this sounds so much easier to me.
Yeah, so it depends if it doesn't tell you which, because I've done it before where I've said use the sum or difference, and I've done it before where I've said, show it two different ways, one way doing it this way and one way doing it that way. But if I don't tell you what way to do it, use the way that you prefer is the easiest. And now that you guys are going to have those formulas on the test, it shouldn't hopefully be as bad. But that trick with a half angle is always just multiply the angle that's given by 2/2. It might have looked real ugly. I saw one that was like, let me see if I can find it again. It was like pi 8s, but it was like a 3 pi 8s. So for instance, I don't know, cosine a 3 pi 8s. And it said use half angle to solve. So to me, that would tell me, okay, I need to manipulate this, and it's ugly because this is a fraction, but I need to manipulate this to be a half angle. And so again, I'm going to multiply by the fancy 1. This time when I multiply by that fancy 1, think of it as a fraction over fraction. We can write that fancy 1 like that. I'm really just doing that more for my numerator piece and not my denominator. So we're just going to manipulate it to look like what we need it to look like so we can use it. But notice when we do that, notice this 2, because we can think of that as over 1. Notice this 2 and this 8, they simplify. And so 2 goes into 8 4 times. So now this has just made that numerator an angle I know for cosine, because now I have this as 3 pi 4ths all divided by that denominator, which is just 2. So this is equal to plus or minus, depending on which quadrant we normally started with, the square root, almost identical to sine, but this time it's plus in between. So 1 plus cosine of what our numerator was before we took the half of it. So 3 pi 4ths all over 2. 3 pi 4ths, that's root 2 over 2. This is in quadrant 2, so it's negative. So this is 1 minus root 2 over 2 all over 2. If I clear my fraction, I get root 2 minus root 2 all over square root of 4 is 2. 3 pi 8ths. I think we looked at that earlier and found that was 60 something degrees. This isn't contained in quadrant 1, so we're going to look at the positive of this. So you should be able to jump and give the following. If you're given your trigonometric functions or multiple trigonometric functions, which quadrant you're in, and then it's asking you to find the exact value of a trigonometric function and its sum of two angles, or the double angle, or the half angle, you're just going to use your formula. So for instance, if you had sine, so find sine of 2 alpha, and you're given maybe sine alpha is equal to -3/5. Pi is less than alpha is less than 3 pi halves. So right there, that just tells me I'm in quadrant. Well, between pi and 3 pi halves, I'm in quadrant 3. And it gives me that cosine beta is equal to 12/13. And that beta falls between 3 pi halves and 2 pi. So that tells me that beta is contained in quadrant 4. Sine of 2 alpha. Well, I have that memorized. I know it's sine of alpha plus sine of alpha. Sine, a sum of angles is sine, cosine, sine, cosine. Sine, cosine plus sine, cosine is 2 sine alpha, cosine alpha. But you'd be given that, and now you would have to, well, we were given what sine of alpha was right here. So that's times -3/5. We don't know what cosine alpha is, but we can find it really fast because we're given what sine of alpha is. So use your triangle. Alpha, so sine is opposite. So this would be 3, hypotenuse is 5. So this one right here, so kind of shortcut, look at your hypotenuse squared, 25 minus your leg squared, 3 squared is 9. So this is the square root of 16, which is 4. We're in quadrant 3. Cosine is negative in quadrant 3, so I have a negative. And then cosine of alpha is adjacent, which is 4, all over hypotenuse, which is 5. Nothing simplifies in my numerator denominator, so just multiply across. 2 times -3 is -6. -6 times -4 is 24. All over 5 times 5 is 25. Okay, but you should be able to do that with your other, like a sum. So tangent of alpha plus beta. You're given information so that you can figure out what things are by making your triangle. A lot of making triangles. Should be able to go backwards. So if you had cosine of 80 degrees, cosine of 20 degrees, plus sine of 80, cosine of 20. Actually, this is sine of 80, sine of 20. Okay. So looking at this, evaluate without using a calculator. Well, 80 and 20 degrees aren't the values that we know, but I notice I have a cosine, cosine, sine, sine. Cosine, cosine, sine, sine with a sum or addition in between flags me that this is a cosine of either a sum or difference of 2 angles. Let alpha be 80. Let beta be 20 degrees. Cosine, it was an opposite sign in between here. So this would be cosine of alpha minus beta, which is 80 degrees minus 20 degrees. This gives me a cosine of 60 degrees. My brain is excited because I know that one, and that's 1/2. Oops. So I'm not going to do it, but you should be able to do the following. So sine, if you have cosine inverse of 5/13 minus cosine inverse of 4/5. You should be able to do this without a calculator. This is where you choose alpha to equal the first inverse trig. If we take the cosine of both sides, we can now do our triangle. Same sort of idea. Choose some other variable to be the other inverse trig, in this case, cosine inverse of 4/5. If we take the cosine of both sides to get rid of the inverse, again, use your triangle. And so here we now have sine of alpha minus a beta. Difference of angles for sine. Sine is sine, cosine, same sign in between. So this would be sine alpha cosine beta minus sine beta cosine alpha. Okay, so from there, you should be able to do your triangle, figure out what the ones you don't know, and multiply that out. I know I'm going really quick. I'm just trying to get through a lot of problems. So I hope that you guys would stop me if you really didn't understand what I was doing. What if you had sine of 2 theta is equal to root 2 cosine theta? Okay, so we want to solve the following equation, and we want to solve it where theta is between 0 and 2 pi. So I would probably rewrite sine of 2 theta. I could use my identity. Sine of 2 theta, by the identity, this is the same thing as 2 sine theta cosine theta is equal to root 2 cosine theta. Notice if we rewrite this, set it equal to 0, we can factor out a cosine theta. So we have 2 sine theta cosine theta minus root 2 cosine theta equals 0. Pull out a cosine theta, then you would have 2 sine theta minus root 2 equals 0. We just rewrote this so it's factored and set equal to 0. So we can set each factor equal to 0. Cosine theta has to equal to 0, or 2 sine theta minus root 2 is equal to 0. Well, cosine theta is equal to 0 when theta, well, cosine is your x value. So when it's on the y-axis, so that would be at pi halves and 3 pi halves. Solve for sine here, add root 2, divide by 2. So we're looking at when is sine theta equal to root 2 over 2. And so it's at pi fourths. But sine is also positive in quadrant 2. So reference angle of pi fourths in quadrant 2 is 3 pi fourths. So there's 4 solutions that would work in that. Pretty much all we have time to do. We had covered on Wednesday or Thursday last week, graphing, again, using shifts and stuff. And so you should be able to graph using phase shifts.